Hello, today we are predicting with linear models. So we are going to do an overview kind of what we're going to learn today, and then we'll take each one of these step by step. So we know that the line that most closely follows a trend in data is called the best fitting line. So for example, if we have a graph, I'll make this a little bit smaller for a second here so I can draw. If I have a graph with my x-axis and my y-axis, and let's say I've plotted a bunch of points, and these happen to be my points that I plot. We can draw a line of best fit that generally follows that trend. It might go through a couple points, but generally some are above and some are below. Now using that line, we can do two things, interpolation and extrapolation. Using a line, or the equation of the line, to approximate a value between two known values is called linear interpolation. So what that means is we're looking between the numbers or the values that we already have plotted. So if I asked you, what's y when x is 3? Well, I could go to 3 on my graph and follow it up to the line to tell you, oh, y is 1, 2, 3, 4, 5, 6, 7. So when x is 3, y is 7. That's interpolation because it's between the data that we already have. Extrapolation is outside of the range of known values. So if I asked you, what's y when x equals 12? Well, my graph only goes up to maybe 6. I would have to be way over to the edge. That would be outside my data, but I could still predict it using the equation of the line. Because if I have an equation, I can just plug that number in for x, or if my graph, let's say it asks for only like 8, and that's outside of our data, we can still predict that based on the trend that we have. And then our last piece of information is called our zero of a function. This is something that we've already learned, it's just a new way of looking at it. A zero of a function, we know y equals f of x. F of x is a fancy way of saying y is an x value for which f of x equals 0, or when y is really 0. So when y is 0, here's our y-axis, 6, 5, 4, 3, 2, 1, 0 would be down here at the bottom. When y is 0, where's x according to our line? And this line, if this continued, would be at maybe like -4. So we need to figure out what that is by plugging y is 0 into our equation. This is also called the x-intercept. We did this when we found x and y intercepts. We found our x-intercept and our y-intercept. For our x-intercept, y was 0, and for our y-intercept, x was 0. Because our y-axis, when we get to 0, that's really on the x-line. Our x-axis, when we get to 0, that's really on the y-line. So let's take a look at these individually. So we're going to first do some interpolation. We're going to do this based on our line of best fit. Well, I already drew our line of best fit and plotted our points. Notice, though, that across the bottom, I used every other line counting by ones, so that if we're going to count our slope, we need to make sure to count 1 as in every 2 lines. So just be careful there, or we can always use our equation. And then on the y-axis, I'm just going by ones. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to stop at 15 there, just so that you know what my scale is on my graph. I just did this so that I used up most of the graph instead of having it all tiny down in one corner. So it says find the equation of the best fitting line. We need an equation in the form y equals mx plus b. But in order to get that, we need to use a different equation. I have a point and I need to find a slope, so maybe let's find our slope first. I'm going to count rise over run, but be careful of your scale. These go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and one more is 11. So we're rising 11, and we're running, be careful, every 2 is one number. 1, 2, 3, 4. 11 over 4. And I cannot simplify that. So we have a slope and we have 2 points. I'm going to use point-slope form because I have a point and a slope. If you'd prefer to use slope-intercept form up here and find v, that's fine as well. So I'm going to plug in y minus y1. Well, I'm going to use this point just because these are smaller numbers. So y minus 4. My slope right here is 11 over 4. And then in parentheses, x minus x1, which is 1. So let's solve this to get y all by itself. I'm going to distribute 11 over 4 times x. And 11 over 4 times negative 1 is still just 11 over 4. I'm going to use my calculator to figure out what that really is. 11 divided by 4 is really 2.75, or 2 3/4. And then we want y by itself, so I'm going to add 4. So those eliminate, and we have y equals 11/4 x. And then negative 2.5 plus 4, there's more positives. 4 minus 2.75 would leave us 1.25. So here's our equation. Now it says approximate the value of y when x equals 5. You can do this either by plugging a 5 into your equation or by looking at 5 on your graph. This one just so happens to be a nice number. When you get to 5, it's 15. But if we want to double check that in our calculator, I could plug in parentheses, 11 divided by 4, that's our slope, times x, which is 5. And then we're going to have to add 1.25. And that gives me 15. Exactly what our graph says as well. So here are some things that we already know. One thing we learned in Chapter 3 was how to solve an equation. To get x by itself, we add just our number first, adding 4. So we had 2x equals 4. Oops, this is supposed to be solved down here. There we go. Those eliminate, and we have 2x equals 4, and then we divided by 2. 4 divided by 2 is 2. We know how to solve equations. In Chapter 4, then we learned how to find an x-intercept by plugging in y equals 0, or by looking at our graph to figure out where we're crossing the x-axis. Now we're finding the 0 of a function when it's f of x, just labeled differently, but we know f of x is a fancy way of saying y, or plugging in when y is 0, just like we did back here. So we solve this the same way we did here. So all we're doing is plugging in f of x equals 0, and are going to solve an equation to find the 0 of a function. So let's do that right now. This is the same thing that we just said. We're plugging in when y is 0, and this is y, so that's really going to be 0. And we want to get x now all by itself to figure out what is x when y is 0. Well, let's just solve. Get rid of addition or subtraction first, so the opposite of adding 3 is subtracting 3. We have negative 3 equals 3 over 2x. You could convert this to a decimal and then just divide by that decimal. Or since it's a fraction, since we can practice getting rid of a fraction, we can multiply by the reciprocal. Instead of 2 over 3, we can multiply by instead of 3 over 2, we can multiply by 2 over 3. So the 2's and the 3's cancel. And then we are left with 2 times negative 3 on the top is negative 6. 3 times 1 on the bottom is 3. So negative 6 divided by 3 is negative 2. Same thing here, we're plugging in when f of x equals 0. This is called finding the 0 of the function. So, get x by itself, I'm going to add 7. So I have 7, 0 plus 7 is 7, equals 5x. And then just divide by 5 to get x by itself. So our answer is x is 7/5. Or in our calculator, 7/5 is the same as 1.4. Either would work. Last one, I want you to try this on your own and then see if you got the answer right. This is really y, so we're plugging in when y is 0. And then getting x all by itself, I'm going to first subtract 6. We have negative 6 equals negative 0.2x. And then the opposite of multiplying is dividing by 0.2. So those are gone. I know two negatives make a positive, but I'm going to plug this into my calculator just to double check. I know what the right answer is. 6 divided by 0.2 or 0.2 is going to give me 30. So 0.2 would go into 6 30 times. So what this means is, if I were to look at a graph, when y is 0, down here, when y is 0, on my x-axis I would be at 30, way over here. On this one, my x-axis would be at 1.4, wherever my line is crossing. This one I'd be at negative 2. So just so you know what that means. Next it says, interpreting the 0 of the function. The number y in thousands of jet boats purchased in the U.S. can be modeled by this function. Y equals negative 1.23x plus 14, where x is a number of years since 1995. Find the 0 of the function. Explain what the 0 means in this situation. So first, find the 0 of the function. Well, that means we just need to plug in when y is 0. So I'm going to plug that in right here. 0 equals negative 1.23x plus 14. So let's solve this. First, get rid of your addition. Subtract 14. So we have negative 14 and negative 1.23x. And then the opposite of multiplying is dividing. So divide by negative 1.23. Those are gone. We have x equals, I know two negatives are going to multiply or divide to make a positive. So 14 divided by 1.23, oops, that's too high, 1.23 is about 11.38. Well, what is x talking about? X is the number of years since 1995. So if we're talking about number of years, usually we talk about whole number of years. So I'm going to just say about 11 years is our answer. So what year is that? If it's been 11 years since 1995, this would be the year 2006. Now what does that mean? The number of jet boats is modeled by this function. We know our slope is negative, so our slope is going down. So our 0 of a function, where we cross the x-axis, is where our money has reached now 0. Or not our money. This is when the number of jet boats reaches 0, because y is the number of jet boats and x is the number of years. So in the year 1995, there were a lot of jet boats, but as the years are going on, the number of jet boats is going down, 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 down. So where we cross the x-axis in the year 2006, that's when there aren't any jet boats left. We don't know if that's true or not, but that's just what this trend showed. Next, interpreting the 0 of a function again. The table shows a number of U.S. households with PCs, or personal computers, from 1994 to 2002. First, we're just going to plot the points. Year is always on our x-axis, and whatever else goes on our y-axis. So I'm going to put on here, all these numbers are positive, so I only need quadrant 1 of my graph. We are talking about years. Years go on my x-axis. And on our y-axis, we're talking about household PCs, number of houses with PCs or personal computers. So my x-axis, I need to go from the year 1994 to the year 2002. If they're talking about the year since 1994, if it is 1994, it's been 0 years since 1994. In 1995, it's been 1 year since 1994. And then 2, 3, 4, 5, 6, 7, 8. So my x-axis, I only need to go to 8, so I'm going to go every other line. 0, 1, 2, just to take up more of the graph. And then on my y-axis, I need to go from about 30 to about 70. So I'm going to go, let's go by tens. No, I'll go by fives. So I'm going to only label every other line. So it'll be 5, 10, 15, 20, 25, 30, just so that I don't have a whole bunch of numbers crammed together. $55, $60, $70, $80. I think that's high enough. Yep, because I only needed to get up to 72. So let's plot all the points. In year 0, we're at about 32. So year 0, we're at, if you want to put a 0 this way too, you can. 0, we're at 32. In year 1, we're at 33.6. In year 2, we're at 38.8. In year 3, we're at 44.0. There's 45. 44 is a little bit less. Year 4, we're at 51.2. So here's about 50. 51. Year 5, we're at 61. 61. Year 6, we're at 66. 65, 66. Year 7, we're at 69. So here's 70. 69 is one less. And then in year 8, or the year 2002, we're at 72.7. So 72.7, right about there. So find an equation that models the number of households with personal computers or PCs as a function of the number of years since 1994. So a function or equation, we want the form y equals mx plus b. If they don't tell you an equation, assume y equals mx plus b. So I'm going to draw a line through these points. Some above, some below. It might go right through 1 or 2. I'm going to say, that's probably a really close line. So if we want this equation, we need to find our slope. So I'm going to pick 2 points on my line to find my slope. Well, I go through this point, so I'm going to use that point, which is x is 7, and y is at about 70. And then I also went through, I'm going to say this point is close enough. At 1, we're at about 35. If you picked different points, that's okay. So I'm going to count my slope. Going up is by 5, so this is up 5, 10, 15, 20, 25, 30, 35. So I went up 35. And over, now these go by, every 2 is one number. So 1, 2, 3, 4, 5, 6. 35 over 6. That's my slope. So I'm going to use my point slope form to start, and then I'm going to solve for y because I have a point and a slope here. I'm going to use this point for x and y because they're smaller numbers. So y minus y1, which is 35. And then our slope, if you want to leave it as 35 over 6, you can. If you want to convert it to a decimal, that's fine too. And then x minus x1, which is 1. So if I distribute this, 35 over 6 times x is still 35 over 6x. 35 over 6 times negative 1. Now I'm going to plug this in my calculator. 35 divided by 6 is about 5.8. So I have y minus 35 equals, and then this minus 5.8. So I'm going to add 35 to get y by itself. Y equals 35 over 6x. And then 35 and a negative 5. If you want, you can plug it in your calculator. We have 35, and then we have negative 5.8. Gives us 29.2, and it's positive. And you guys, some of you may be confused there because I typed that in the other way. It doesn't matter if you type in negative 5.8 plus 35, because the 35 is positive in both cases and the 5.8 is negative in both cases. So you will get the same answer. So here's our equation. In terms of an equation, if you wanted to get rid of that fraction, it would be y equals 5.8x plus 29.2. And think, does this 29.2 make sense? Yep, I cross my y-axis at 29.2. That's my y-intercept. But our zero of our function, what they're wanting next, is to find the zero of the function and explain what does it mean. So our zero of a function is when we're going to cross the x-axis at 0. So if this pattern continued, our graph would continue to go this way to get where we're crossing the x-axis. So it would be somewhere over here. I'm going through my numbers. So we know it's going to be a negative number. But instead of trying to predict that, we're just going to plug in when y is 0. And solve to figure out where will that be on my x-axis. So we're going to subtract 29.2. So we have negative 29.2 equals negative 5.8x. And then divide by 5.8 to get x by itself. So negative 29.2 and then divided by 5.8 gives me negative 5.0 something. So I'm just going to round it to about negative 5. It was 5.03. So that makes sense. If I were to go back 5, it would be right at about 5. So that means, in what year was this at 0? This was the number of PCs. So what does this mean? This answer, it's going to be 5 years before, well, what was year 0? Year 0 was really the year 1994. So 5 years before 1994 is when what happened? When what was at 0? And our y-axis was the number of houses with PCs. Is when there were 0 houses with PCs. Because there had to be a time when no one had personal computers, and then we went up as time went on. This graph just started at 0 instead. That is our lesson for today. If you have any questions, please make sure to ask. Otherwise, your homework is drawing a line of best fit for the scatter plot, predicting either using your equation or the graph. I would suggest using the equation to get a more accurate answer. And then there are a couple where you have to find the zero of a function. Remember, that's just plugging in when f of x equals 0. And the last two, making your scatter plot. writing an equation in the form y equals mx plus b, and then approximate the profit in August. So this one's since January. If it's 0, that is still January. So count the number of months it would be until it gets to August.